Ever feel like scientists are wizards? They conjure new materials like it's magic potions, but what if they had a secret weapon, like something to boost their brain power, help them unlock even more? That's what this deep dive is all about. We're talking about AI designing experiments.
Okay, I like where this is going.
Not just playing games well, kind of like playing games, but actually figuring out the physical tests that tell us how materials behave. Everything from the phone in your hand to like rockets launching into space.
It's wild, right? What's so cool is that designing a good experiment, it really is like a game of strategy. Think about it. You've got limited resources, right? A whole bunch of decisions to make. And the goal is to get the absolute most valuable information out of those resources.
Right. Like you've only got so much time and money to work with. You got to make it count.
Exactly. Traditionally, that's meant a scientist relying on, I don't know, gut feeling, years of experience, that kind of thing. But these papers we're diving into, they suggest AI might be able to kind of outmaneuver us, especially when things get crazy complex.
AI outsmarting scientists? Is that what you're saying? I'm in?
Laughs. Well, in a way, one paper even calls it a meta-modeling game. So instead of chess, it's like the AI is playing sim scientist.
I play that game.
They actually represent these models as graphs. So picture this. Each important quality of a material is like a dot, right? Tensile strength, how much it bends, even stuff you need a microscope to see. All dots. The AI has to figure out how to connect them, like it's drawing the lines that represent, say, the relationship between how flexible something is and its melt-off point.
So it's not just crunching numbers, it's learning the actual physics of the material. That's pretty wild.
Exactly. It's getting to the heart of what makes a material tick. And the researchers found that the AI often came up with these beautifully simple, elegant, experimental designs that humans just wouldn't think of. Like, it was taking a completely different approach.
Hold on, it gets even wilder. Some researchers are putting two AIs against each other, right? Like a science showdown.
Yeah, it's called the protagonist-adversary approach.
Yeah.
It's like, okay, imagine training a world-class athlete.
Rocky theme song playing.
Exactly. You've got one AI trying to build the best possible model of a material that's our protagonist.
Training montage.
And then you've got this other AI, the adversary, that's trying to design experiments that will make the first AI's model completely fail. Like a sparring partner that just keeps pushing you to be better.
So this constant back and forth is making both of them stronger, smarter. But what does this actually mean for, the real world? This isn't just a theoretical AI face-off, is it?
No, not at all. This research suggests that AI could drastically cut down the time and cost of developing new materials, which, let's face it, impacts everything. We're talking building more efficient solar panels, finding lighter and stronger materials for cars and airplanes.
Okay, so big implications.
Yeah.
But this isn't about replacing scientists, right? It's more like giving them, a superpower.
Exactly. Think of AI as a superpowered research assistant. It helps scientists explore the material world in ways we simply couldn't before. The possibilities are really mind-blowing when you think about it. It's like giving scientists the superpower to explore materials in a whole new way.
Okay, I'm kind of following. But how does this work in practice? Like, how does AI grapple with something like testing the strength of a bridge? I mean, it's not just about the steel or concrete itself, right?
You're hitting on a crucial point, which is that the history of a material really matters.
Like how if you crumple up a piece of paper, it's weaker in those spots after.
Exactly. That's what we call path dependence. Think about like a paper clip. You bend it back and forth enough times, it's going to break, right? But it's also easier to bend in the future because of how you treated it before.
So it's not just what it is, it's what it's gone through that affects how it behaves.
You got it. And that is a nightmare for scientists trying to model materials accurately because you got to account for all of it.
Yeah.
Every little stress, every strain, every temperature change, everything it's ever experienced.
So how does AI even start to process all of that? Like, how's it keep track?
Well, one way is with something called a recurrent neural network, an RNN for short.
Yachi?
Right. These RNNs are basically built to handle sequential data. Think like language, the order of words matters, right? Or stock prices over time. And yeah, the entire loading history of how a material has been stressed or strained, that matters too.
So the AI is, reading the material's diary? Seeing all the good times, the bad times?
In a way. And that means AI can design experiments that don't just test a material at a single moment, but they actually take that whole history into account. It's really powerful stuff, and it allows us to design much more robust structures in the end.
Wow, so it's like giving the material a personalized workout plan or something tailored to its past injuries and all.
Now you're getting it. Because in the real world, things aren't usually under just one constant force. Like a bridge isn't just holding up a steady weight. It's got to handle traffic, wind, all these dynamic forces over time.
This is mind-blowing, but I have to ask, if an AI designs some brilliant new experiment, how do scientists actually know it's right? Like, how do we trust it?
That is the million-dollar question, and it's something that researchers are really grappling with right now.
So what's the solution? How do we make sure these AI Einsteins are giving us, like, good, solid answers, not just lucky guesses?
It all comes down to building trust and transparency into the system. Imagine if the AI could not only design the experiment, but also explain its reasoning. Like, it's showing its work, just like you'd expect from a student in a science fair, right?
Okay, now that would be impressive. Like, here's my experiment, and here's why I think it'll work.
And that's the direction the research is heading, making the AI's decision-making process much clearer so scientists can understand the why behind the what. That's huge for trust.
So it really is about partnership then, not replacement. Like giving scientists this super smart partner in research, not just replacing them altogether.
You got it. And that partnership, I think, has the potential to unlock some really, really incredible discoveries in the coming years.
This is seriously groundbreaking stuff. We've covered so much ground, from like AI learning the language of materials to this whole wild world of path dependence and having AI partners in research. But before we get too far ahead of ourselves, let's maybe bring things back down to earth for a second. You've been deep in this world, so for someone like me who's just starting to wrap their head around it all, what are the key things to remember?
Well, we have covered a lot. I think the most important takeaway is that AI-driven experimental design, it's not some futuristic fantasy. This is happening right now, and it's making waves in fields you might not even expect.
Like what? Give me some examples.
One of the most exciting areas is in the development of new materials. Think about it. Stronger, lighter materials for things like airplanes, or more efficient solar cells for clean energy, or even biocompatible materials for things like next-generation prosthetics.
So AI is basically helping us build a better future, one experiment at a time.
Exactly. By analyzing these massive data sets of material properties, AI can help pinpoint promising candidates, and then it can design those really targeted experiments to fine-tune their properties for specific applications. It's like having this tireless assistant working around the clock to discover the next wonder material.
Okay, that makes sense for like airplanes and solar panels and stuff, but what about things that hit a little closer to home? You mentioned this could even change healthcare, right?
Absolutely. One area where AI-driven experiments are showing huge promise is in personalized medicine. You know, right now we kind of have this one-size-fits-all approach to treatment a lot of the time, but imagine if we could tailor therapies to each patient's unique needs.
So instead of just getting a general prescription, it's like you're getting custom-made medicine designed just for you.
Exactly. AI can take into account all sorts of data, your genetic makeup, your medical history, even things like your lifestyle, and use that to figure out which treatment will be most effective for you. It's like having a whole team of doctors working behind the scenes to create this personalized healthcare plan.
Wow, that's incredible. It sounds like AI is going to revolutionize pretty much every aspect of our lives.
It really does have that potential, but of course, we do have to be cautious as well.
What do you mean? Are there, like, risks with all this that we should be aware of?
Well, whenever you have a really powerful technology, there's always the chance it could be misused, right? So it's crucial to make sure that these AI systems are developed and used responsibly.
So it's not just about what AI can do, but also what it should do.
Precisely. We need to be having these conversations about ethics, about bias and data, about making sure these AI systems are aligned with human values. We can't just let them run wild.
Right. We don't want to create a future where AI is making all the decisions without any human oversight.
Exactly. The future of AI-driven research has to be a partnership where humans and machines are working together to advance our understanding of the world.
And hopefully making it a better place in the process.
That's the goal, right?
So we've talked about AI designing these really cool experiments, but there's this whole other level to it. It's almost like, could AI uncover secrets of the universe that we'd never even think to look for?
That's the really exciting part. AI can explore so many more possibilities than we can, even with the biggest, most powerful computers. It's not limited the same way we are.
So it's like AI could be looking in places we wouldn't even think to look.
Exactly. It could be coming through data, making these crazy connections that lead to totally unexpected breakthroughs, things we'd never find on our own.
Like a scientific plot twist. Okay, so for someone like me who's just starting to wrap their head around how huge all of this is, what are the key things to remember about AI designing experiments, if I had to boil it down?
Well, I think the most important thing is this isn't science fiction. We're not talking about some distant future. AI-driven experiments are already happening right now in labs and research centers around the world, and it's only going to get more common from here on out.
So this isn't just like a niche thing for scientists with supercomputers. Anyone can get in on this.
It's definitely not just a niche thing. I mean, anyone who designs and runs experiments, no matter what field they're in, they can benefit from what AI can do. Think of it like, I don't know, having a secret weapon in your research arsenal. It can give you an edge.
Okay, so it's like having a superpowered lab assistant that never sleeps and is constantly crunching data and coming up with ideas.
Exactly. But, and this is important, it's not as simple as just feeding data to an AI and then, boom, you've got these amazing discoveries. It's a partnership.
Right, so it's not like AI is going to replace scientists entirely. It's more nuanced than that.
It's way more nuanced. AI is an incredibly powerful tool, but it is just a tool. You still need human expertise, human creativity to ask the right questions in the first place, and then to make sense of what the AI finds, and of course to make sure that everything is being done ethically. We can't forget about that.
So it really is this collaboration, almost like a dance between human scientists and these AI partners, right?
Yeah.
Figuring out how to work together to get the best results.
I love that analogy. It's a dance. And it's a dance that could unlock some seriously groundbreaking discoveries. We're really on the edge of a new era in scientific exploration, and it's incredibly exciting to think about where it might lead.
That is incredibly exciting. But also, I have to admit, a little bit intimidating, you know?
Maybe a little, but I think it's more about seeing the possibilities than being intimidated. Think about it. We're living in a time where the tools of scientific discovery are evolving faster than ever before, and that's a good thing. It means we can tackle bigger challenges, explore new frontiers, and maybe even answer some of the questions that have baffled us for centuries.
That's a really great point. So to all our listeners out there, consider this a call to action. Don't just stand on the sidelines. This revolution in research, it's happening now. Jump in, learn everything you can about AI and how it can be applied to your work. And who knows, maybe you will be the one making the next big breakthrough.
I can't wait to see what the future holds. It's going to be amazing.
Thanks for joining us for this deep dive, everyone. Until next time, keep exploring the cutting edge of science and keep asking those big questions.